Court did a good job of introducing me, but I thought I'd maybe go a little bit further. I've been working in technology, particularly in security, for a little over 20 years at this point. Back in the day, when I was a network administrator at a university, we didn't really have a dedicated security department. So I was doing what you would call DevOps at the time, writing tools to deploy our infrastructure in and around our environment. I've been heavily involved in open source security for my entire career, starting at a university where we had minimal budget. We needed to make the most of all of our dollars. And I've found a sort of a niche way to really try to level up a lot of open source security projects. Here in Boston, I've taught a Bro workshop probably about a half a dozen times now. And I travel around and I just do those for free. I've done over 130 at this point, but I really believe in the community. I really think it is a more progressive and a better path forward. I've worked with hundreds of teams doing deployments in security, and if there's any reason why you should listen to me, it's because I've seen so much failure across enterprises, government agencies of all size. So what I'd really like to do today is share some of the advantages and some of the perspective about why you should choose open source security. Finally, I've worked with not only HackSecure, but HackReduce as an investor. And I've invested personally in some of the amazing work that's happening here in Boston. And when I did my most recent startup, even though I don't live in Boston, we still chose to build our development office out here. This is a really special place to me. It's such an incredible community that has this phenomenal capacity and talent pool to get things done. So here's my contact information. I'm pretty easy to find. I'm also a very happily married guy with 3 little kids. With that in mind, let me just first say a couple things. The first thing is that I'm the world's worst mind reader. So if you guys can't hear me in the back, or some of my slides aren't clear, or if you have questions, just put your arms up. I would like to make sure that I'm helping to inform you, and we can go from there. So with that being said, let's get started. So I'm going to start by talking a little bit about what I think the real root problem is in security and how open source helps to address it. I'm going to talk about why I think that most of the security that we're doing today is bullshit and why it's a waste of time. Then we're going to talk about some practical steps that people can do. Most of my talks are probably a little more technical and in the weeds, but today we're going to pull it up and we're actually going to talk to a couple of the different archetypes that you find in a modern security organization in order to give each of you a sort of set of to-dos and talking points. And then finally, we're going to talk about why open source security is winning, why startups that embrace it are winning, and why it's definitely the model of the future. So this is where I really wanted to start. It's that if you look at the news, if you work in a security organization, you have to feel a lot of times, especially on the defensive side, that we're terrible. We absolutely suck, and we can do nothing right? And it's somewhat, the odds are stacked against us. Attackers need to be successful once. We need to win all the time in order to be considered good at security. And ultimately, though, I think that there's a lot of lessons that we can take and learn out of that failure. That we can really try to iterate forward and find things and models and companies that are doing it right or patterns that work better and go from there. Let me actually just shut this and go to a mic. One of the big reasons that we continue to fail is that we sort of have this commercial security monoculture where every single organization just buys one of everything. You start with your email scanning appliance, then you move to your network scanning appliance. And people have standardized on these perimeter security controls. And people that are in the industry sort of understand that every new technology sort of has a limited shelf life of 12 to 24 months before the threat actors themselves have an opportunity to study these things, figure out what sort of models that they're applying. Are they statistical based? Are they anomaly based? Are they signature based? And then develop evasions to get through those models. And if you're in security and you're working especially at a large organization, you sort of see this. You see the threat actors iterate forward in their models looking for what's more effective. They apply lessons learned from their attacks, and we should absolutely do the same thing. And I'm not saying that I'm above the fray. I've been teaching Bro workshops and security workshops for a long time. So I think that there's this general problem, though, in that almost everything we do here is at the bottom of the pyramid. Does anybody know who David Bianco is? He was actually at a pretty amazing Boston startup here called Squirrel, if you guys know that one. It's the NSA cumulative spinout for a little bit, although I believe that he's moved to a different opportunity now. But David Bianco has been working in incident response for a long time. And he did this blog post a few years ago that I think really helped to describe the problem very effectively. And it's that most of the things that we spend our time sharing with each other, going after, are the things that threat actors don't really care about. You know, we spend time looking at domain names and IP addresses and file hashes. And those things just don't matter to a threat actor. If you share badguy.com and you block that at your firewall, what is the threat actor going to do? They're going to go to badguy2.com. It's not until we can start to develop larger scale heuristics that attack the real TTPs, the tools, tactics, and procedures of the threat actors, that we're really going to make a difference. So let me give you a simple example of that. Does anybody know what DNS tunneling is? Okay, so a couple people. So DNS tunneling is an example where you implement a protocol almost like a VPN, and you have it ride on top of a standard protocol. And there are other types of tunneling. There's HTTP tunneling. There is ICMP tunneling. So this isn't just particular to one particular protocol. The first time I saw DNS tunneling in the field was at a defense contractor in 2012, being leveraged by a nation-state threat actor. So this is definitely stuff that happens. And these techniques have sort of migrated downstream, if you will, and are now being leveraged by even smaller organizations. But with DNS tunneling, what we have is you can have a computer, for example, your SQL server or your mail server, something like that, that cannot get out to the internet normally, right? It's completely blocked. But it has access to your internal DNS. It might be a Windows, Active Directory domain. So this is Microsoft SQL Server or something like that. And you've prevented it from getting out to the network. But it can certainly speak to your internal Active Directory servers. So what the threat actor does is, after they deliver a payload to this box, cut this actually. All right. Test. Is this going to come up? Here. 1, 2, 3. No?
Try this one.
All right. I'm loud enough to fill this room.
Test.
All right. Okay, that was getting annoying even to me. All right. So with DNS tunneling, what we have is it's sort of a method to evade the security controls on your network. And if you're looking at it on the wire, it'll actually look a little something like this here. Let's see. Okay, in the back, can you guys read that okay, down at the bottom there? Yeah? Yes? No? All right, we're at bad mind reader here. Let's go. All right, so this is an example of what DNS tunneling looks like on the network. You have two hosts that are speaking DNS to each other, and the remote DNS server that actually hears this or receives this query is running a version of DNS that knows how to decode this channel here. And so what you're looking at is these are normal requests where normally you would use this channel to do something like, say, turn www.cnn.com into an IP address. But here what's happening is we're using this channel to have a conversation over it. And so we move the information out of the network like this. When we talk about a signature for this, if we wrote a signature that said that they're using DNS tunneling to badguy.com, let's block badguy.com, that would stop that one particular instance. But if we really want to make a difference here in the security space, what we really need to do is to go after the TTPs. So with DNS tunneling, for example, there are 4 different communication channels that you can use over DNS tunneling. So that's kind of a nerd way of saying that I could leverage that protocol. I could use the DNS options, or in this case, that last case, I was using the DNS subdomains. Instead of going to www.liam.com, I was going to message1.liam.com, message2.liam.com, message3.liam.com. So one easy method would be to simply count the subdomains, and when we cross some threshold, fire an alert. Now, that's a simple example, but that's an example of going after a threat actor TTP, one of their tools, tactics, and procedures, because that is where we really start to cause them pain. If we're going to continue to exchange these more basic things like domain names, IP addresses, and file hashes, we're done for. It's just not going to happen. But if we deploy that detector, that last one was written in a programming language called Bro, we can really cause them pain. If you bring those lame tactics on my network, for example, I will catch you in a second, because we look for those kind of things. We have millions of signatures. We know of, actually there's billions of signatures when you think of things like virus total and file hashes. But those aren't what we find effective in our network. It's really when we start to go after these sort of root causes in security. And I think that's really my point today, is that we keep on doing the same things over and over again in security, in application delivery, in these phases, and we're not talking about what the real problem here is. And the real problem is really kind of upstream from there. It has to do with the way we operate our organizations. It has to do with the way we build and run infrastructure. It has to do with problems that may not even traditionally be thought of as security problems. And there's a lot of things that we can leverage in open source to do that. Now, finally, the last reason that we should move to open source is the sort of big dirty secret in security. And that's that regardless of what you're using, most of your tools that you buy from commercial organizations are actually open source projects with different UIs on them. Or they're collecting metadata from these open source projects and then analyzing it using different methods. So when you understand that perspective, you really start to understand that tools are defined by their engines. And when most tools are from a monoculture of engines, your limiting factor is not what I build around the engine, it's the engine itself. So that as a security professional, you would be better to at least have direct access to be able to change your engine, to update your engine, than you would be to operate just a standard commercial tool there. So when we're thinking about all these different pieces of security, I don't know how many people today are incident responders or are in management or in developers. There's really a hard thing to do when you're giving any technical talk, never mind a keynote, in saying, how can I deliver this content in a way so that it resonates with as many people in the organization, in the audience as possible. All right, there are a couple hundred people here. There are a couple hundred different actual understandings and perspectives on technology and on security. So what I thought we would do today is start with a simple model organization. And I'm gonna take similar content and I'm gonna deliver it in a way that the CISO, the average developer, and the average incident responder can sort of understand here. So let's get started with who I think, the place where I think we can make the biggest difference, and that's in application delivery. Let's talk about Developer Dave. Right, so Developer Dave essentially is challenged with the whole point of why we have information systems departments. It's to deliver applications, right? So much of what we're doing when you think around what technology I pick, what platform I run it on, what database engine I pick, the real point is simply that a user needs to consume this information through the UI. And people have lost sight of that. And in losing sight of it, what they've done is they've really pushed the security problem outside of the domain. It's like that the little chubby kid who's saying my feet hurt, but not looking at the fact that he's incredibly overweight here, right? If we can address the security problem upstream when we're building and running these applications, then we don't have to worry about securing them downstream, or at least we can minimize what we need to do downstream. And this model has been adopted by the absolute leaders in the technology space. When you look at how Google and how Facebook and how Amazon and how my own employer, Capital One, build, operate, and run their infrastructure, you sort of have seen this trend over time here. We've moved away from requiring our developers to bring a full PC, even a full virtual machine, and we've moved towards lighter weight methods of application delivery. Now, let me put yourself into one of three buckets here. I'm using containers, I've heard of containers, and I might use them. No idea what the heck you're talking about. So if you're using containers now, raise your hand. Surprisingly large amount of people, and I would attribute that to the awesome tech in the Boston space. I've heard of containers, I'm going to use them. A couple people, I'm lost, where are we? All right, so the remaining people. But a surprising number of people here are already leveraging these kind of technologies. And if you haven't heard of this space before, if you haven't looked at this, essentially what we're doing is we're minimizing what you're responsible for. When virtual machines came out, we simply said, okay, developers, stop worrying about the underlying hardware. That's going to be elastic for you. You don't have to worry about maintaining the hardware. You don't even have to worry about, to within certain boundaries, scaling that hardware. Maybe you're going to couple that with an early microservice type model where you're going to say that I can scale the application independent of the hardware that's underneath it. Containers are a really sexy and sweet space to be in. I think they're even sexier than a serverless. When you think about serverless, that's literally, so containers are, I'm going to take a container, I'm going to put my application and the libraries I need to execute it in a box and pass that around. Serverless is, I'm just going to give you my application and you can execute it. Serverless is nice, but its big flaw right now is that it's not easily portable. Right? It's very hard to take a serverless, Lambda app right now, or maybe not very hard, it's not seamless, and migrate that out to another cloud or infrastructure provider. But these containers really give us this modular and isolated application delivery. But the real reason that they're the ideal deployment format is simply because they're backwards compatible, right? You can take those capital assets that you've built and been investing in for the last couple decades, the code, the IP, the libraries, and simply just repackage it into a container. So you get the portability, you get the backwards compatibility, and when coupled with a microservice, you also get the scalability. Let me go back to that last one here. When we're thinking then about operating these particular types of containers, I think people are starting to realize that I want to minimize the amount of things that I'm doing here. But that's sometimes not what we see when we're out looking at container land. And we're gonna illustrate that with a demo here in a second. For those of you that are still kind of circling around this space a little bit and saying, well, how does this compare to my current infrastructure? Think a little bit about the vendors that you might find in each one. In virtual machines, you probably have heard of OpenStack and VMware and Hyper-V and Amazon EC2. In containers, my own company, CriticalStack, actually built a container orchestration platform around Kubernetes. There's Mesosphere, there's Amazon, there's Docker. What's interesting in this space is that an open source library called Kubernetes has absolutely come to dominate it. The container comparison that big organizations pretty much do now is it Kubernetes or I don't want to look at it? Because Kubernetes, people are sort of understanding that they're saying, well, I want my container to be portable. I want my container orchestration to also be portable, right? So developer Dave, is building their application in a microservice model, running it on top of Kubernetes, packaging it up today in a Docker container, but soon in a different container format here. But when we're thinking about packaging these things up, landing on the container is the first step. But what people are forgetting already from a security perspective is how do I optimize that container for delivering it securely? So for those of you that are using your containers, I would ask and wonder, what are you starting with from your base? When you're thinking about what do I put in my container, you can do a lot here to minimize your footprint. And we're gonna do this by way of an example here. If you've never built a container before, essentially you can think of them like layers. You can start with a base, like you could say from Ubuntu or from Alpine here. I want to add some different tools here. So here we're adding one. This is building a feature for Kubernetes called SkyDNS, and then I can launch that. And this is now this portable box that I can take with me from place to place. Now, when I first started to get into this programming language called Go, which let me do the 3 buckets for Go. Using, gonna use it, WTF. Who's using Go? A lot of developer days, okay. Who wants to use it? Who's learning, right? Getting there, okay. When I first sat down and learned about Go, I had one of those moments where I really felt incompetent. And that's a very hard thing for me to come up and say, especially when I'm giving a keynote, but I think that our industry has this rapid fire trend of rolling over 100% of our knowledge every 33% a year, right? 1/3 of what I know this year is got to be new, which means everything else that I used to know can somewhere just drift out of my brain, like config.sys. Why do I still know about that, right? That goes back to the 90s there. And when I first got into Go and I learned about Scratch containers, I really had this epiphany where I was like, man, when Google introduced this container code into the Linux kernel 15 years ago and designed a programming language around it, these things were going hand in hand towards this modern container model that we're all operating on today. If you read about what Google calls Borg internally, and they've somewhat open sourced with the Kubernetes model externally, you really start to realize that there are people that are thinking very deeply about this problem and designing upstream tools and infrastructure in a way to minimize the security vulnerabilities and footprint. So to demonstrate this, what I've done is I've written a little web shell. Now, who knows what a web shell is? Okay, so a web shell is a file that I would want to put on your web server that gives me remote control, right? And this is a common, first a foothold into an environment. I will scan your network and I'll look for a file uploading vulnerability. A massive healthcare hack that I ended up working on, here's what we saw. When you went to sign up for healthcare at this particular company, you had to upload, my application.jpeg.pdf or .img, a couple other image formats. And we actually looked at our logs and we watched the threat actor experiment with changing different MIME types, the extensions, and eventually they figured out that they could do upload my application.png.php, and the developer was just looking for the .png, and then the web server, when it saved it, when he went to look at his application, he said, I want to open my application online and look at it, and it actually just executed his PHP code, right? And so that threat actor was able to put a web shell on there that gave them remote control. Now, I put this up on GitHub for you guys to look at, and let's just take a look, oh, the guy wrote a web shell. This is like such a simple example here. Okay, so this is a simple Go program, and we're going to use this to simulate, your line of business application here. Hold on. Better in the back? You guys read that okay? So what we're simply going to do is we're going to run a web server, and whenever somebody passes us or interacts with our web server, we're going to just turn and execute that code and then just display it to the browser. So this is like the minimum viable web shell that you can have. And I think at a security conference, it seems like a great idea to run this live on my local laptop. Maybe it's not the best idea, and maybe I'll hear about this later. But let's show you decreasing our application footprint through good application architecture. All right? So on my laptop here, I'm running Simple Exec Mac. And OK, let's roll this up. OK, in the back, can you guys read that OK? And what I can do here is I can run like ls, and I could look at the directory. And I could interact with it here by looking at, say, the root. All right, this is the root of my live Mac here. I think somebody over here is running nmap and looking for my computer, going to try to teach me a lesson about being a show-off. So I think at this point it's a race. I could look at like my .ssh directory, and I could even like cat out one of these files here. So let's look at secure. And I wasn't really going to show you an SSH key live on stage. That would be ridiculous. But this is obviously not a good idea. And what am I doing wrong here? One, I'm running this big fat application on a big fat PC. And there's lots of tangential security space that I need to keep up with. If a threat actor gets access to my box, they have all the tools they need to pivot to other places in my organization. If I'm exposing this to the internet, something like Bashbug would easily be able to, maybe not easily, but if I have a vulnerability, would be able to pivot it and take care of this. So let's kill that before I hurt myself. But let's look at what else I have on this box here. What I've done is I have taken this web shell and I've packaged it up in a couple of different kinds of containers here. And let's go back to the presentation. I'll show you what I got. What I tried to do was to take some common container formats here. A container that's called a Golang dev, one that's Ubuntu. You guys probably all know Ubuntu. A minimal container called Alpine, and then this from scratch container, which simply just has simple exec in it. So those Docker files are up on that repo. It's up on my personal GitHub if you want to look at them. But think of this in your mind, what we're doing here. We're building this portable container that we're going to take with us. And in the first container, we're putting in not only the Go programming language, but all of the supporting tools and libraries. So it's a big container. It's 709 megabytes. It takes us a long time, relatively, to compile, although that's probably not the biggest constraint. It may take us a long time to move around. It'll take longer to scale. Let's say that you're all my Kubernetes execution nodes here, or we're running on CriticalStack or something like that. If we have a scaling event, before I can scale that container on another adjacent workload, I need to be able to get that container there. So we've already sort of maximized our exposure to some certain types of attacks here. Even as we go into something like from Ubuntu, we have a significant amount of extra cruft compared to just the plain from scratch application here. So while this is ideal, I think what really shows it is when you do from latest, here is what these footprints actually look like. Now, I've just used the Claire open source scanner here to scan through these containers here. But out of the box, here's the number of vulnerabilities that come in these containers. And of course, the people that are building containers are going to be like, Liam, but of course you're going to do an apt-get update when you build that container. Of course you are. But you're also still bringing all of that crap with you in your container. You haven't taken the step yet, developer Dave, to say, hey, let's minimize this so that if I accidentally deploy a bug or if I have a problem, can I minimize the amount of surface area that I'm putting out on the internet? I'm going to make my attackers' jobs harder for them. So I have all of these containers here running across a bunch of different ports here. And you can see that getting on here in the first one, this is the Golang. We still have a similar sort of problem, right? I still have lots of cruft that's on here. I could look at home. I'll look at, what do we got here? Bin, right? There's lots of tools for me that are on here. And as I move down through, this is now Fedora, we still have similar types of issues, right? We've got even more tools here in this particular issue. This is just a standard from Fedora. And as we get into Ubuntu, we still have more. We still have just as many problems here, but this is now a smaller workspace. But finally, I get to Alpine. And in Alpine, it's this minimal container that's designed to just put the minimum amount of things that I need to execute and troubleshoot it. But I don't think it's still really ideal. It's certainly better than using from Golang or from Fedora or something like that. I have significantly less tools here. There's about 40 or 50 executables in here. But then finally, this is our from scratch, right? And so with from scratch, I don't even have freaking LS in the box, right? There's nothing in the box for the threat actor to pivot to. It's the only thing that's in here are the libraries that I need and my application itself. And I guess the most devastating thing that I could do here would be to, let me do this. I'm going to launch simple exec in my container, right? So, well, I'm going to fail launching it live on stage, which is just as good because that kind of proves my point. Oh, there we go. Didn't have the capital E. OK, so now I just launched my container in my container, right? Otherwise, a threat actor is going to have to bring all of the tools that they want for pivoting into my environment. I don't have Netcat in here. I don't have compilation utilities. So if you're a developer, Dave, and you really want to make a huge contribution to the security of your organization, I would strongly encourage you to move to a more sustainable, scalable, application deployment technology like containers and really try to minimize what you're putting in those containers as well. Because you're essentially working on one of the root causes of security when you do that, right? Taking a step back there. So that's developer Dave. So next we'll go to incident responder Will Liam, whose advanced security who struggles with security. And that was a little screenshot of me there. And I've come into Boston 6 or so times before, and I've done these Bro workshops. And if you haven't looked at Bro, it's a network tool that really lets you extract a lot more information, metadata, from your network so you can make better security decisions. But I've done that one before, so I'm going to talk about a new one, something that I've started working on since I joined Capital One. And I want to talk about my motivation for trying to do it first. So this is sadly a real screenshot from an organization, I'm not going to say which one, that I was brought into to help them with security. And this is one of their off-the-shelf security tools. And it may be a little hard to read in the back there, but it says the tool PSExec is whitelisted, which is a utility that I can use on a Windows network to launch a program on your computer. So it has multiple use cases here. And it's actually whitelisted, so no logs are ever generated. And the whitelist comment is Microsoft software, not malicious, which is literally like saying, take these bullets, they only kill bad guys, right? That is not how bullets work, and that is not how tools work, right? So my motivation for starting this project was to help incident responders like Will Liam, or like many of you, I suspect, and give them some additional tools or some additional techniques to understand tool usage on their network. And we're building out 2 different versions of this at my organization now. The first is Sysmon, which is our 1.0. It's Windows only. And our 2.0 is actually OS query. And we're building it, we're going to run it on every single device in our network. And I would do today's talk around OS query because it's a tool that I'm incredibly enthusiastic about. I actually invested in an OS query startup here in Boston that's affiliated with HackSecure and HackReduce. But I didn't want to come up and talk my book like that. Besides, they're going to be here later today talking their book, and they're going to do a way better job. Mike Arpia and Jason Meller, I would watch for them in the 12 o'clock slot. But my design, so instead, I'm going to show you guys Sysmon, which is a free tool from Microsoft that has incredible and immediate security benefits. So while it's not open source, it is open, and the configuration that I'm going to show you today, we are opening and releasing as a white paper later this year. So our sort of design criteria were that 1, we would build something very lightweight, 2, it was flexible, 3, that it supported highly structured metadata. This is a very common problem in security analytics. People will take something like a bro log, and then they'll map it to syslog, right? You had a highly structured data type, and you unmapped it, then you need to write a parser to fix that. So we wanted to make sure we were extracting our logs here, in this case, Windows event logs, leveraging JSON, so that when we got them to an indexing database, something like a Squirrel, or we're using Elk, you basically could easily search and hunt through these things and link them across different data types. And then ultimately that we're scalable. We operate on something like 12% of US credit card transactions. And so if I can't build it for our scale, I wasn't really interested in it. So Sysmon is this tool that was developed by Mark Rusanovich. You may know him as the person behind SysInternals. He was sold his startup to Microsoft, and is now actually the CTO of Microsoft Azure. So he works on a lot of the cloud stuff. And it has this a very simple language and a very simple configuration that you guys can use to develop it. And this is the language that you have access to. And this is an event-based language. And if you haven't worked with an event-based language, it's basically like answering phone calls. Sysmon gives you a phone call whenever one of these things happen, and then you can choose what you want to do with that phone call. So it'll say, hey, we have a new process. What would you like to do? Now, the Sysmon language is very limited. So in this case, you can pretty much choose to log it or not log it. But that model, even just that basic functionality, just that one question that I can ask and maybe have some if-then-elses, is really powerful. Hey, there's a new network connection. What would you like to do? Hey, I'm loading a new driver from disk. What would you like to know about it? Right? This event-based language, you can use this to very rapidly tune a configuration for your network. So what we do is we started by just deploying Sysmon with no rules. and we had a metric crap ton of data. That is a technical measurement. It was a lot. And we immediately started deploying whitelists and suppressing information that we didn't want to see to minimize the amount of logs that were coming in. This is the opposite approach of a data lake, what we're taking for this one. We have a data lake. They collect all the things. They're using machine learning. They are advanced. They are all the buzzwords, right? But I wanted this to be very focused and practical, right? I only want a log if it's interesting, if it's not expected on my network. So that way it minimizes the amount of stuff that I need to go through. And we then push a new config, which generates new logs, which we then whitelist, and so forth. So this is our iteration cycle around and around. And within a couple days, we tuned our message volume down to a couple hundred interesting messages per workstation per day. Now, a couple hundred is certainly a lot on a massive network, but we wanted some data so that we could do frequency analysis. So we wanted, for example, the hash of every process that executes on my network. Can you answer that about all of your infrastructure now? Because when you can easily just look at the tails and ask yourself questions like, why is this run 37,000 times a day? Why is this only run once? It minimizes and gives you a very approachable way of understanding your network. And if you've never, I understand that not everyone here is an incident responder. We clearly had some developer Daves, and I was talking to a few of you beforehand. I know we have some more management types here. If you've never done hunting before in your network, here's the trick. There's only 2 steps. 1, ask a question, and then 2, answer it. That's the definition of hunting. And you tenaciously answer those questions, asking the 5 whys, and continuing to drive yourself to close. This is pretty much what I've done for my entire career. So the questions that you would like to ask yourself are things like, what are all the hashes running in my environment? What are all the processes communicating on 53, 80, and 443, right? DNS, like our DNS web shell, HTTP 80, or 443, TLS, or SSL, right? Those are the common ports. You could obviously run whatever you want on there. Collect the logs. Other questions. Show me all processes whose parents are command.exe. So if you're a developer or an administrator and you run as and you sudo up to a shell here, we have the ability to see every single command you typed in, right? psexec, and so forth. So this is what the rule language looks like here. In this case, we're answering a phone call and we're saying, hello, there's a new network connection. What would you like to do? If it's on 80, 443, 53, 445, 135, or 3389, this is a SMB and Microsoft Remote Desktop, log it. Because this is the hunt mission that I'm running right now. Unless it's Internet Explorer, Chrome, Firefox, or DNS.exe. Now, I moved these to the file names as opposed to the file hashes, which would obviously be a better way to tune this. These would whitelist and say, you could spin up a piece of malware called Firefox.exe, and it wouldn't show you. But if you do your exclusions with your file hashes for your environment, that's obviously a better technique. And there's examples that we're going to put up in the white paper. So then we build these tuning dashboards. So we know that, OK, well, this thing here in the blue is run on everything. So let's go ahead and shut that down. Let's go ahead and suppress that, because everybody has the VPN client speaking on 443 in my environment, for example. This is not really the port it runs on, but just as an example. And then to find our rules, what are we hunting for? We did a gap analysis with this Unreal project out of MITRE called the Attack Framework. And if you haven't looked at this in your environment, this thing is amazing. It gives you this entire clickable list of types of attacks, like persistence mechanisms, privilege escalation, defense evasion. When you click on any of these, it'll take you into techniques, tools, and procedures for each one of those things, so that you understand, how do I actually find this in my environment? I mean, good God, who can keep up with all these different kinds of attacks? How can I find a simple explanation of it with associated metadata for even testing my alerts? This even shows you how to execute many of the attacks. So if you write a detector for pass the hash or something like that, you have the ability to come in and figure out how to run it on your network to validate your controls. Then we identified, right now we've got close to 40 analytics, and we gave them a priority level that's relative to our environment, how susceptible we felt that we were to those, how devastating we felt they were, a simple description, and then we started to push these things out. And it's been unbelievable the amount of things that we could find. All right? And so we're using an open tool here to solve a problem, and we buy one of everything. We're a big bank, right? Literally have one of everything. We've got more interesting metadata off of this open project that we're sharing rules with right now in a very limited trust community, but we're going to open it up to other people soon. We've been able to literally watch people on the command line typing things like net time, running the @task scheduler, and then building out Elk dashboards to sort of show us these. We did a readout the other day with our red team, and I actually showed them our red team dashboard, where we literally have like a dashboard for each different pen tester because they all have their own little quirks. You like to rename PowerShell to a.exe, which does evade, believe it or not, many common big name vendors because they whitelist based on the file name as opposed to the hash. You like to rename it to Brent.exe, and Brent, if you watch this talk, I'm sorry for calling out your technique. You're going to have to rename it to Brent2.exe next time. We've been able to see things like leveraging that PSExec tool that we just saw in the previous example, understanding the context that it was used in to see that somebody was, in this case, launching a remote command shell on a remote box, right? PSExec is used all over our network for good purposes, but this gave us the ability to identify those, whitelist them, and then just see what remains. It's a very powerful and easy and interesting technique that has a high value impact. We actually started this project with zero budget. It was a total black project in our organization. A bunch of us just literally logged into Slack at night and continued to work on this and refine it. This is going global in our organization. Here's an example of Excel. So we have a dashboard that looks for Trojaned Word documents. So we look for a parent of Office, Excel, Word, PowerPoint. And then we look for children, PowerShell, C script, W script, ... And if you've ever heard of fileless malware, or if you're in financial services, people just flipped out a few months ago over this particular technique, that's what it looks like. And it stands out. It doesn't look anything like a normal Excel launching a PDF or something like that. Right? It doesn't look anything like that in your environment, at least in our environment. And believe me, we have one of everything. Right? So these techniques are very easy to move on to. So that was for incident responder. Right? Get better metadata and analyze it quicker. We started with developer Dave. We went to the incident responder. And let's kind of work towards a close here with our CISO, Phil, the classic pointy-haired boss. And ultimately, if you're in management, even if you're not at the top, you have a lot of massive problems. You have everybody telling you everything's advanced. You can't segment your vendors. I wanted to add a link in here to a talk from Sunil Yu, who's taking a very interesting technique. Sunil's the mad scientist over Bank of America. And if you Google him, he's got this really cool talk where he takes the NIST cybersecurity framework and he maps it to the functional domains. So you can actually like box in a vendor and say, okay, this is a detective tool for endpoint, detective for users. This is a preventive tool for endpoint, preventive for users. So I'll work on expanding that out and getting this up here. But this is probably what you look like if you're in management, right? I hear about tools that I need to buy from my vendors, and then I place requests for those. And ultimately, this does not work because it doesn't address the modern security paradigm. And this modern security paradigm that you need to coach your management on, if you haven't already, is that prevention is impossible, right? You're going to be compromised. It is simply a matter of when, right? Your actual job, your function as a blue team member in security is to minimize the risk of loss due to intrusion, not to stop intrusion, because you can't have a goal that's impossible, right? Because it doesn't realistically set the stage correctly. It doesn't give you the ability to prioritize and work from here. Oh, I didn't change that should actually say hack secure. Sorry about that. To get on the problem, are you in the Florida room in Texas? Are you in the Texas room in Florida? I sometimes have that kind of issue traveling around a lot. Let me move this forward for you, though. If you're in management, strategic security really begins with you. Because what you need to do is you need to coach people and get your management to set the goals, because there's some subtle tricks here. One, when you get them to commit to an open goal, something like minimize the risk of loss to intrusion, you can nail their ass to the wall with it, right? Don't be in a situation where you have all of the responsibility but none of the authority, right? At least set yourself up for success with a program like this. If you're at the top, you're the CIO, you're the CISO, maybe depending on how your organization works. Once you accept that as your paradigm, suddenly then you get to set the strategies. And you can say, well, we're going to be compromised. Our strategy is rapid detection. We're going to be compromised. Our strategy is rapid response and containment. We're going to be compromised. So for application delivery, our strategy is containerization and microservices. Minimize that footprint, right? Do you see how it kind of lines up now and you set yourself for success? So when you go back to them and say, well, we need funding for training on containerization. We need funding for research into Kubernetes. How are we going to take this stuff to market? You can absolutely point to a strategy that makes sense. And you can also put it back on them. For large regulated organizations, Congress is actually considering passing a rule right now that you need to do a disclosure about the cybersecurity competency of your board of directors. Crazy stuff, right? Now coming down into the more functional areas, this is where we start to bridge the gap from strategy into tactics. This is often where people fail. They say, we're going to do advanced stuff, but we have no freaking clue how to do it. Pivot back to that gap analysis with the MITRE ATT&CK framework, for example, of an easy way to transition from strategic priorities down to your tactical results. And then as an operational leader, you're like the colonel if you're a military person, right? You're identifying hunt missions and you're executing on them. You're saying that, okay, mission one is that we're going to match and hunt for intruders. We're going to understand who are the people that attack my industry, right? Is it threat actor, what type of threat actors? We're going to line that up to the techniques they use. We're going to pivot into the MITRE ATT&CK framework, for example, line that up, and then we're going to simply implement those in our environment. How susceptible are we to those different things? How do we prioritize them for implementation on detection? And then moving down into the area, only then do you start thinking about how I do things, right? You stop letting the vendors drive, what am I going to do this year, and you start driving from the top down. And only at the bottom here do you finally decide, once I figure out what I'm trying to do, now I can pick a tool, right? It may sound like common sense, but this is typically not how it works in most organizations. So I really appreciate everybody's time today, and I just kind of wanted to wrap it up and think about what we're really, at a 50,000 foot view, what we're doing here. We're really moving away from what let us all be successful for the last 100 years. When you think about the giants of the last 100, 200 years, it was all about scale. Identify this widget, and it's all about driving costs down. It's about scaling it and executing across as large of a surface area as possible. What modern organizations really need to prioritize, whether you're a security function, a developer function, a management or strategic function, is really agility, right? You need to drive towards being able to respond rapidly in an advanced environment. When you think about why startups out-innovate large companies, this is the reason why. This is what you have to do to build software at a giant company or organization, right? If you're a startup, if you're at a big company, you don't fail, you don't get your lesson learned until all the way on the right. If you're in a startup, you're driving and failing quickly. You get to learn down here. It's a huge strategic advantage. If you're looking for some management literature or even just a great story, I would highly recommend this book, Team of Teams by General McChrystal. He really crystallizes and talks a lot about the last a generation of success versus the next. And it's told through this colorful and unbelievable story about how he transitioned modern special operation warfare for the sort of current threat actor environment. But it's applicable to every type of organization, I think. And to show you that this isn't just happening across startups or insurance or financials or whatever sort of functional domain you're in, CriticalStack, my company, was the first recipient of a new type of agile purchasing authority from the federal government. So when you try to take this back in your own environment and you say, hey, we need to do this today, we need to get agile, we need to get fast, we need to fight for this, a great little one-liner you could drop on your bosses is, hey, are we as agile as the US government? Because they recognize the problem. Senator McCain actually sponsored that. He said, the way we do business is the problem. That's why we get crappy results. So at this point, I think we've talked enough about build, measure, learn. I'm probably at time, but maybe one or two questions if people have them. and we'll go ahead and go from there. So does anybody have any questions? Yes, sir.
Totally different, but is it possible to share your slides because very difficult for us to
I'll repeat the question. Is it possible to share our slides because it's difficult to write down all of your amazing content and all the brilliant things you said? Is that about it? Yes. This will actually be hosted up on the HackSecure site, and copies of the slides will be right there. Other questions? All right, guys. Well, I'm going to wrap it up, but we've got an amazing crew coming out here today, so I look forward to the next couple hours of awesome talks. I'll be hanging around if anybody wants to chit-chat or talk. Thank you for your time.